Hi everyone, my name is Alex Castle. I'm a software developer at Google, and I've been working with the Next.js team on a number of projects, but most recently on the image component that's shipping in Next 10. I'm really excited about the image component. I think it's going to be a popular, useful new feature. I think it's going to make it a lot easier to add images to your Next.js application. Mostly I'm excited about it because I think it is going to make performance better for any application that uses it. There are a lot of image-related problems that can really hurt your site's performance. And there are solutions to those problems, but you have to kind of know about them and you have to take the time to implement them on your site. I think that by building these solutions into a platform-level feature like the image component, we can really make Next applications as a whole a lot faster. So I'm going to talk today about 5 of those problems. And these are all issues that we've seen in real production Next applications that have noticeable performance impacts. And then for each of those problems, I'm going to talk about what you can do to fix it and how we took that problem into account when we designed the image component, and then why you should use the image component because it's just going to sort of make that problem go away for you. So hopefully by the time that we're done with this talk, I've made a pretty good case for why you should at least give the image component a try. But even if you can't, I think that just discussing these issues, discussing the solutions for them will be something that's useful to any Next.js application. Before we begin, there's one important question to answer, and that is when I say performance, when I say that the image component will improve performance for Next.js applications, what do I mean exactly? And that's kind of a tricky question because there have been a variety of ways to test web application performance over the years. And it's an important question because whatever we choose to measure, whatever metrics we focus on, strongly influences the optimizations that we choose to do. So I thought I would share the metrics that I've been paying the most attention to, and that's what we call the Core Web Vitals. It's a newer metric from Google. And unlike some previous metrics, the Web Vitals are a field metric. And that means that the metrics are based on actual user data, people's actual experience of visiting your sites, what loading is like for them, how long do things take, how much do things move around, that sort of thing. And I think they give you a very practical and sort of easy to understand distillation of performance on your site. I won't go too in depth on what the Core Web Vitals are, but broadly speaking, they are how long does it take to paint the biggest thing on the screen to the screen during load? How long does it take before your JavaScript is interactive, before your site can be interacted with? And then also how much does your layout shift around as the page loads? I think that those all have a lot of bearing on what it's really like to visit a page, so improving those will really improve the user experience. I would encourage everyone to look at the Core Web Vitals for themselves. If you want to find out more information about the Core Web Vitals, you can go to web.dev/vitals. So the first image performance problem I want to talk about is improperly sized or unresponsive images. This is one of the simpler problems out there, but it is also one of the ones that can have the most outsized effect on performance. Basically, this is when you've got an image that is small on your page or medium on your page, but served large. Perhaps it is a 100 pixel wide avatar on your page, and then it is being served as a 1500 pixel wide, 200 kilobyte file. As these add up, often you'll have the same problem multiple times on your page. You can end up serving a megabyte or multiple megabytes of completely useless data to your users. Especially if your user's on a metered connection, this is wasting their money. Even if they're not, it's basically making your site less pleasant, less responsive to use. So there can be a simple solution. Perhaps you just need to serve a smaller image, but often this is made more complicated by the need to support multiple devices, multiple breakpoints. Maybe the 100 pixel wide image I'm seeing actually is being rendered at 1500 pixels on someone else's display. So the solution that is most appropriate is the source set property. This is something that I'm sure a lot of you are familiar with. It is a property that goes on the image element. It allows you to define multiple source URLs instead of just one. So instead of getting the same size image no matter what size the user's viewport is, you get a 500 pixel wide image below a certain breakpoint, a 1000 pixel wide image below a certain breakpoint, and so forth. I don't want this to be like a source set tutorial. I'm sure a lot of you already know how they work, but if you want more information, there are plenty of guides available. Web.dev has one, MDN has one. You can just search for image source set and you'll find something good. And yet, source sets often aren't used in the wild. When I look at sites, I still see a lot of sites that are serving images that are too big, no source sets anywhere. And I think the reason this is that they're basically just a little difficult to use. They take more effort in terms of additional, a large additional property on each one of your images, just having to think more about how the image is going to be rendered, having to know about source sets. That's something that not everyone is familiar with. And then also, importantly, having a image hosting strategy that actually supports having different sizes for each image. And that can be something else that needs to be configured. So that combination of it being a problem that can cause major performance issues, having a good solution to the problem, and yet also having a lot of people not use it, made it seem like sort of the perfect thing to include in the image component. And so that's exactly what we did. We made it so that when you use the image component, you get a source set for each image out of the box without you having to include any properties beyond what you would normally include on an image element. How that works is that you define the breakpoints that you care about based on your layout and what you know about your users. And then each image that you put on the page automatically gets a source set with generated URLs for the different widths that you specified in your breakpoints. So the images have to be served in a way that supports that dynamic sizing. And fortunately, that is also very easy with the image component because we support a number of CDNs out of the box. If you're using something like Cloudinary or ImageX, you just have to specify your host and it'll work automatically. But even if you're not using a CDN, you can use the new Next Image Optimizer, and that will allow you to give it these dynamic width URLs, and automatically it will give you the right size images. So you get the source sets, and you still don't have to do any configuration on your own. So I think that this is going to be a really useful feature in that it's going to allow basically everyone to take advantage of source sets and avoid the problem of serving images that are too big for the user. Next up, I want to talk about image formats. This is a little different than the last section, and this is not a mistake that applications actively make. It is more like a optimization, an easy optimization that applications don't take advantage of. And it is a big optimization. A modern image format like WebP is on average 25 to 35% smaller than the equivalent image in a PNG or a JPEG, and even more modern files like AVIF are smaller still. Because images tend to make up a large share of an application's overall sort of payload size, a 25% or 35% decrease in image size can really have a noticeable effect on your entire application transfer size. This is particularly relevant to the largest contentful paint metric that I mentioned earlier, since that metric is strongly dependent on when the biggest element on your page, which is very often an image, loads. The smaller you can make large images on your page, the better your LCP metric is going to get. The problem with using modern image formats is that not all browsers support all formats, and if you want to serve the modern formats just to the browsers that can take advantage of them, that requires either using a CDN or setting up a somewhat complicated image server on your own. With the image component, we want to once again make this something that is just easy for everyone to use. And again, if you use the image component, you will get this feature without really having to do anything on your side. The next image optimizer means that that somewhat complicated image server is now built straight into Next, so you don't need to do anything there. Or if you are using one of our supported CDNs, we default to auto formatting, whatever auto formatting that CDN provides to make sure that you are taking advantage of the feature where you get the proper image format based on the browser that is requesting that image. So once again, this is not something that you have to do, it's just something you should know about the image format, that you are getting this benefit and that you should expect your application's performance to increase accordingly. The next problem I want to talk about is loading too many images. This is basically if your application is longer than a single page, if there are images that are well below the bottom of the page, there's really no need to load them up front. You want to wait until the user indicates that they may actually want to see those images by continuing to scroll down the page, and then load them as needed. Especially for e-commerce pages, other pages that have a lot of images, maybe in like a grid of some sort, this can be a major performance gain to not be loading every image right up front. The solution to this is a pretty widely used technique called lazy loading, where we don't actually request the image until the user has scrolled down. The biggest problem with lazy loading is actually that there's a lot of ways to do it. It's sort of confusing to know what is the right way to do it. There's a built-in lazy loading feature, but it doesn't work on all browsers. There's you can use the intersection observer. You can attach something to a scroll event, and like some of the other issues we've talked about, even though there's a well-understood solution, some people just don't implement it, and you can have performance problems as a result. The way that we handle this in Next.js with the image component is just by providing lazy loading as a default feature of the image component. So we have an intersection observer-based approach to lazy loading, which is the most widely supported approach right now. And any image that you don't mark as a high priority image and that you don't give the loading equals eager attribute to will be assumed that you wanted lazy by default and will behave accordingly. Basically, again, we don't want the users of the image component to have to think about it too much. This behavior should just be appropriate for most use cases. And in the use cases where you want a different behavior, you can specify that in the image component. Next up, we'll talk about preloading images. This is a problem more than the other ones we've talked about so far. This is kind of specific to Next, and it is even more specific to Next in the server-side rendering mode. If you are doing static generation, this doesn't really come up. But basically, the problem here is that Next prioritizes CSS and JavaScript assets over images by default, which makes sense because even with server-side rendering, you can't show anything on the client until the CSS has been downloaded. And you do still want to get the client hydrated as soon as possible to get the JavaScript running. That's generally going to be more important than just getting some arbitrary image on the page. However, there are some images that we actually care about more than the JavaScript. Specifically, anything that's like right at the top of the page, your hero image, maybe a carousel image at the top of the page. And this is because the whole point of server-side rendering is that we want to be able to show the users a version of the site that looks complete even before we've gone through the rather slower process of actually downloading the JavaScript and bootstrapping the sort of single-page application version or the serverless version of the page. So what we want to have happen is those images which are important, which are the hero images, should get a preload, and that preload will give them priority over the JavaScript. And when I say preload, I mean a link element with the type equals preload. With the image component, this is not necessarily automatic. I've looked into sort of programmatically detecting the most important images, and it's a pretty challenging task. So the current best solution is to give people the opportunity to identify which images they believe are the hero image of their page using an attribute called priority. So for the ideally 1 to 4 images that you believe are going to be kind of the hero section of your page, you apply the priority attribute, and then the image component automatically adds a preload link into the header for you. Again, something that you don't have to do yourself. The preload includes the source set preload, which is kind of an experimental feature right now, but as that becomes more available, that's already present. And just generally, this is something that we expect to improve the largest contentful paint on any site that takes advantage of it and does go to the effort of adding those priority tags to the images where they're appropriate. Finally, I want to talk about the problem of unsized images. So the normal image element has a height and width property that can be used to size the image, but generally are not these days because they don't provide very fine-grained control over the sort of layout behavior of the image. But these two properties are actually quite important in a way because they are how the browser's layout engine knows how much space to leave for the image while that image is still loading. When it first gets the rendered HTML from the server, the browser wants to start showing you the page as soon as possible, even before it has made a connection to the image server. It wants to create space where that image will pop into being once it downloads. But until that download begins, the browser does not know what the shape of that image is. From the CSS, it can tell how wide the image is going to be generally, but it cannot tell how tall it's going to be because it doesn't know, again, the shape of the image. So the end result is, as these images start to download and the browser sort of properly discovers their aspect ratios, the page shifts around, which is a bad experience for the user. And in fact, it's such a bad experience for the user that that's just one of the Web Vital metrics. It's cumulative layout shift. It's how much does that happen? The more it happens, the worse. You want the page to ideally just immediately assume its final form and then stay there. So with the image component here, we're doing something a little different than the other ones, and that we can't quite give this to you for free, but it enforces a best practice that will make your application much better for your users to use and also perform better on these Web Vitals metrics. And that is that the image component by default enforces a height and width. It has a height and width property, and you have to put them in or your build won't go through. The height and width are actually, they don't size the image at all, unlike in traditional image elements. They just define a ratio. So actually, even if you don't know the exact height and width of your image, if you know the ratio, if you know that it's a 3 to 4 image, you can put those in and it will work fine. Of course, we acknowledge that there are circumstances in which, for some reason, you just cannot know at authoring time how big an image is going to be. There is another attribute called unsized that you can add that will basically turn off the requirement that you size your images, but we essentially recommend that you do this as little as possible. Your users will thank you for it. Going forward, we're also going to be releasing a set of ESLint rules that will further recommend best practices for the image element, things that maybe are not built in, but that we strongly recommend as you adopt the image element, as you are sort of revisiting how your images are included in your page, that you take this opportunity to implement some of these best practices and make your site as performant and accessible as possible. All right, so that should about do it. We've talked about 5 image performance pitfalls. To recap, we talked about responsive images, about the importance of delivering the right size image for the right size device or viewport. We talked about image formats and about how using a modern image format can really increase your application's performance. We talked about lazy loading as well as network priority and the importance of preloading some of your images, as well as which images you should preload. And then we talked about why it's important to include a height and width property on your images in order to prevent layout shift. Hopefully, as we went, I have also done a good job of explaining how the image component sort of solves most of those problems for you, or in the cases where it doesn't solve it for you, it at least provides you new tools to sort of solve it for yourself. There are features of the image component beyond what I've touched on here, and I also only barely talked about the image optimizer, which is also a very exciting new thing for images in Next. I hope you take the time to explore the image component and optimizer. I think the best way to do that is just to try it out yourself. And I think by doing that, you'll discover that it's really a efficient way to add images to your application, and that it improves your performance across the board. Thanks for listening to my talk. I hope it was helpful. The image component is brand new, so please, if you have any feedback for me, or constructive criticism, or if you want to contribute to the image component, I am available at atcastle at Twitter, or on the Next GitHub.